Hey guys, Mrs. Traver here. We're going to walk through notes on parallel and perpendicular lines, but instead of traditionally walking right into these notes, I want to actually show you an example on a Desmos activity that we did in class first. So let's look at that. Here's an example that it gives us. It says graph a parallel line. And I think that we already all have an idea on what parallel means. Those are two lines that never cross. We were given the blue line, y equals mx plus b. We don't really know what that line is, but we know that it's a blue one. And we're able to move around the m and the b to, we were given the purple line. We're able to move around the m and the b to our blue line. So I want it to be parallel to that dashed one. So notice right now, I'm not quite there yet. If I move this way, ooh, that actually looks good. So if I move this way, I start getting negative. Here's all my negatives. Right here at 0 on horizontal. I start getting positive. I'm getting closer. And right now, I'm right on top of that dashed line. Now, let's see. I need to move my B as well. It says through the given point. So the point is way over here. I need to move my B. If I move it up, my line gets further and further away from that dot. Let's move it down. And now right about here, there we go, I'm through that line. So here's what I want to show you that we hopefully learned from this part, is that we've got two parallel lines. Whatever the slope was on this dashed line, we had to match it in order to get these to be parallel. Because if it was any other slope, then it was gonna eventually hit it somewhere and not be parallel. So the deal with parallel lines that we're going to learn is that they have parallel slopes. That's the first piece of our notes. We're going to do that with this graph. So I've given us two different equations, and we're going to graph them. I've got two different colors going on too. So my first one, a review of graphing, I'm going to start with my slope or my y-intercept at positive 3. And then our slope is 2, so that means rise 2, run 1. And if I run on a graph, I can go the other way, drop 2, go left 1 as well. It's nice to give yourself as many points as you can across your coordinate plane. So yours is as exact as you can make it. Or if you have a ruler, then you're even cooler. I don't have one right here. My next one, I have a y-intercept at negative 2. And the same slope, up 2 over 1. I can connect those guys. It's nice to extend your graph to the edges of the screen. So here we go. Those are our two lines. Those are parallel lines. And the thing we want to notice here is that we've got the same slope. We just moved it to a different y-intercept. So here's the deal, is that parallel lines have the same slope. So for example, if I gave you the line y equals 5x minus 2, and I said find any line parallel to that, you just have to pick a line where the slope is 5, and you could have anything here, literally anything could go in that spot. As long as these match, then you're good and you've got a parallel line. Let's do a different type of example next. So kind of like what we did in our Desmos activity. Let's say that we had a problem like this. Let's see. 1 second, let me pause our screen. All right, let's look at this example. So if I have a line, if I'm looking for a line parallel to y equals x minus 2 through a given point, first notice a line parallel. This is our symbol for parallel. It looks like an 11, but it's taller and closer together. But that means parallel. So I'm looking for the equation of some line parallel to this one that goes through this point. Well, I know my answer, I need to look like a line. So I need my answer to look like y equals mx plus b. And I know for this that I need to plug something in for m and something in for b. Well, based on what I know about parallel lines, I can pull the parallel line slope from the original line. So since I want to be parallel to this guy, I just need to steal its slope. And its slope is hiding right here in invisible 1. So I've got my m is 1. And I don't have a b yet, but I can get it by plugging in an x and a y. I was given that. So let's do that. I can plug in this x and this y and this m and get a b. So y is 4, m is 1, x right now is also 1, and I don't know b. 1 times 1 is 1. Subtract it off, and I've got 3 equals b. So now I've got my b my m. I have everything I need for my equation, the m and the b. So my final answer here, the line that is parallel to y equals 1x minus 2 and 3, 1, 4 is y equals 1x plus 3, or just x plus 3. There we go. All right, let's do a little looking at perpendicular list now. Let's go back to our Desmos activity. Let me move over to the one I want. Here it is. No, not this one. There we go. All right, so it says we were given this purple line that's dashed, y equals negative 2/3 x plus 3. We want to adjust the sliders of a and b to graph the purple line so it's perpendicular to the blue one. So notice they gave me y equals a over bx. And I can move my numerator and my denominator, a and b. So let's see. Our original equation was negative 2/3. So let's see what happens first. If I were to match it, negative 2 over 3. Those are parallel. We already went over these ones, but we don't need parallel anymore. We need perpendicular. So I need to go through and intersect one time at a 90-degree angle. If you remember from geometry, that's what perpendicular means. So first off, notice if it's going to cross this guy, it needs to not also have a negative slope. So let's try and see what 2/3 would look like. Ooh, we're getting closer now with 2/3. So we started with negative 2/3. Now we're at positive 2/3. That's closer. But notice that this is an obtuse angle set here as vertical, and this is also an acute angle set. I need those to both be right. Let's try something different. Let's do 3/2. And notice now that is much more perpendicular. So what we're going to end up coming to find out is that when we have a negative reciprocal, it's going to create a perpendicular line set. So that's what our next example is going to be like on our notes. All right, so here's a couple lines. We've got y equals negative 2/3 x plus 3 and y equals 3/2 x minus 2. So again, notice what's going on with these two slopes. That's what we're trying to refer back to. The slope on this guy was negative 2/3 and on this guy it was 3/2. It looks like they're flipped and then one of them is negative. So what we're going to say here is that perpendicular lines have negative reciprocal slopes. And by reciprocal, I mean the flip. So if you need to switch the numerator and denominator, that'll give you the reciprocal. So for example, if I gave you, let's see, 1/4, the negative reciprocal, I would flip the 1 and the 4 to be 4 and 1 and make it negative. And then I could simplify this to be negative 4. So this would change to that. Or maybe I started with a 3. I could imagine there being a 1 under it and then flipping them. So this would be equal, this would change over to, not equal to, negative 1/3. So you can see we flip it, and we make it negative, and that'll give us the perpendicular set that we're looking for. Let's do one more example then, and we'll call it a day, similar to the last one we did. So, all right, so say we had, we're looking for a line perpendicular to the line y equals negative 1/2 x minus 3, and through the point 2, negative 5. First notice I threw a symbol in there for you again. This is the symbol for perpendicular to. It looks like a perpendicular line, so that's helpful. It's an upside down big T. So first let's figure out our slope. If we started with negative 1/2, we need to go to the negative reciprocal of that. So we need to flip it and make it the negative of whatever it was. Well, it's negative right now, so the negative of a negative is going to be a positive. And I need to flip it, so this is going to give me a positive 2. So my slope is 2. So m is 2. And I'm trying to get ourselves into y equals mx plus b again, because I want a line. So I've got my m, and I don't have my b yet, but I do have an x, y. So I'm going to do the same thing as before and plug in my x, my y, my m to get my b. So let's do that. Y is negative 5 equals m, which we said was 2, times x, which was also 2, plus b. 2 times 2 is 4. And we'll subtract it off. So negative 5 minus 4 is negative 9 equals b. I've got my b, I've got my m, I've got my final answer. A line perpendicular to the line negative 1/2 x minus 3 has an opposite reciprocal slope or a negative reciprocal slope of 2, and it has a y-intercept that we solve for as negative 9. So there's my final answer on that guy. I hope these notes have helped you out. The main deal here to remember is that parallel lines have the same slope and perpendicular lines have negative reciprocal slopes or opposite negatives. I will see you next time.